Okay, so here's some help for this Chapter 4 test review sheet for this test that's coming up. So let's get right into it. This first problem deals with recognizing whether a given table of values represents a line, linear, or does it represent the function or the graph of something that's not linear. So here's what this amounts to. You're basically just going to do the slope. So slope, remember, is y2 minus y1. So if I wanted to find the slope for this first set of points, I would do 3 minus negative 2, y2 minus y1, divided by x2 minus x1, and I end up with 5. So then I'm just going to, to make sure, I'm just going to continue working my way through the table and see if we continue to get that same result for slope every time we do the next set of ordered pairs. So we'll see if we can do some mental math here. Y2 minus y1, 8 minus 3 is 5 over 1. Okay, so that gives me the same number. And then if we move down a row and then we do 13 minus 8, that's 5 over 2 minus 1. Still 5. So I feel pretty confident then that this is going to be linear. The definition of a linear function is we have a constant rate of change, and that constant rate of change is called the slope. So the directions are determine whether it's linear or not. We've done that. And then if it is linear, state the slope, and the slope is that constant number that always comes up when we do the slope formula. So the slope is 5. So that's your answer for problem number 1. Number 2, Marissa must decide between one of two companies. For a phone provider, company A charges a monthly fee of $7 plus 6 cents per minute. Company B charges a little differently, no monthly fee, but a little bit more per minute. So the linear function that relates cost to total minutes for each company. So for company A, cost is going to be the 6 cents per minute, and I'll just let X represent the number of minutes. And then we've got this monthly fee of $7 that isn't dependent on how many minutes are used. So there's the equation, the linear equation for company A. And then for company B, a little different. Their cost is going to be 8 cents a minute and no monthly fee. So the number of minutes for which the bill from A will equal the bill from B, we just let these two, basically these two equal each other and solve for X. So I'm going to subtract 0.06x, left off the X there, subtract 0.06x from both sides, and I get 0.02x. And then you're going to divide by 2 on both sides, or 0.02 on both sides. 7 divided by 0.02 is 350. So for 350 minutes, the bills would be equal. Both company A and company B would charge the same amount, in other words. All right, over what interval of minutes will the bill from company B be less than the bill from company A? So let's just set that up as an inequality. So company B's bill less than company A. So it's going to be the same type of deal. We're going to end up with, of course, 0.02x is less than 7. And then dividing by 0.2, x will be less than 350. And since minutes cannot be negative, we need to write this as an interval, because if we just left it like this, then we're including numbers like -25, -300, and x represents a number of minutes. So the domain really should be, we might have 0 minutes, can't go below 0. So that would be the interval using an inequality, and then using our typical interval notation, we would say 0, 350. And that takes care of number 2. And I just realized before we move on to number 3 and 4, you could have, I think I said you could have 0 minutes, so I should have made this or equal to, but less than 350 down to 0, but we can't go below 0. Okay, so problems 3 and 4 are all about graphing, coming up with information about the graphs. So number 3 is nice because it's already in what we call vertex form. So I can see the vertex, but I'll just go in the order that these letters are provided. So letter A says determine whether the graph opens up or down. It opens up because the number in front of the parentheses is +1. All right, so letter B, well, this is all part of letter A, so sorry about that. Find its vertex. So again, this is called vertex form. And so the vertex is going to be -1, -4. Remember, this represents a shift of 1 to the left. So be careful about the x-coordinate of the vertex. The AOS is going to be x equals -1. It's the x-coordinate of the vertex. The y-intercept, we can't see the y-intercept just by looking at standard form, so we'll have to do what we've done in the past and just let 0 go in for x and simplify. So if I replace x with 0, I get 1 squared, which is 1, minus 4, and that is -3. So the y-intercept is -3. The x-intercepts, this is where I'll let y be 0 and solve for x. So I'm going to add 4 to both sides. I'm going to do the square root of both sides. And then I'm going to subtract 1 from both sides. So my x-intercepts are going to be -1 plus 2, which is 1, and -1 minus 2, which is -3. All right, so we've taken care of all of letter A. So let's just go ahead and start putting all this together. Vertex of -1, -4. Y-intercept of -3. AOS, x equals -1. So I can match this point up, y-intercept point. The x-intercepts are +1 and -3. And it looks like that's going to help me with the graph. I just connect those dots. There's the graph of the parabola. And then part B says the domain and range. So I'll just put this down here. Domain is always the same. It's just all reals. The range, however, it starts at -4. And then it's going to continue to go up from there toward positive infinity. And then where is the function, the graph increasing and decreasing? That's all about the x-coordinates of the vertex, and it's decreasing on this left side. All right, so where I'm highlighting in red. So that's from -infinity to -1. Remember, it's about the x-coordinates, about increasing, decreasing. And then it's decreasing, oh, sorry, I got that switched. This should be the decreasing. -infinity to -1. And then it's increasing on the other side, so this is the increase. And so that's going to be from -1 to positive infinity. All right, that takes care of number 3. Number 4, let's go ahead and set this up. So this is going to open down. It's negative in front of x squared. Find the vertex. You could change this into vertex form. We've done some of that. Or if you prefer to do the opposite of b over 2a. So the opposite of negative 1 over 2 times negative 2, which is negative 4. So the opposite of positive 1/4 is negative 1/4. And now to find the y-coordinate of the vertex, I just plug negative 1/4 in for x. And simplify this. So negative 1/4 squared is 1/16 times negative 2 is negative 1/8. And this is plus 1/4. And I'm just going to go ahead and change this into 16/4. All right. I guess I'll change it into eighths. I just noticed that first one's in eighths. So 1/4 would be 2/8. And 16/4 would be 32/8. And now we put it all together. So negative 1 plus 2 is 1, plus 32 is 33/8. So that's the same thing as 4 and 1/8. All right, so that means our AOS is x equals negative 1/4. So this is our vertex. Here's the AOS. The y-intercept in standard form is easy to see. It's just the constant. The y-intercept is 4. The x-intercepts we'll have to solve for, so it's negative 2x squared minus x plus 4 equals 0. And so we'll use the quadratic formula, I guess. So opposite of b plus minus square root of b squared minus 4 times negative 2 is negative 8 times 4 is negative 32 all over 2 times negative 2, which is negative 4. So now you'll just go to your calculator and come up with those 2 decimals. So I'm going to do 1 plus the square root of 33 divided by negative 4. And that's negative 1.69. And now I'm going to do 1 minus the square root of 33 divided by negative 4 is 1.19. Okay, so let's just go ahead and start putting all this together. So negative 1/4, just to estimate where you think that is, just to the left of y-axis. And then the y-coordinate, that's just saying 4 33/8 is 4 1/8. Just a little bit above. The y-intercept is 4, so these are real close together. Real close together. Kind of hard for me to separate them. But there's the y-intercept and its match. And then the x-intercepts, this is almost, it's about negative 1.5, pretty close. And this is just a little bit to the right of 1.19. And so we connect those. There's our graph. Now we just do the rest of the information, the domain and range. So we know what the domain is. All reals. The range is going to start at this y-intercept 33/8, or sorry, y-coordinate of the vertex, and then it's going down. So the way we say the range would be from negative infinity to positive 33/8. And let's see, increasing, decreasing, and then we're done. So it's going to be increasing on the left side this time. So this is the increase half. So from increasing, we'll say from negative infinity to that x-coordinate, negative 1/4. And then it's decreasing on the other side. And there's our answer for number 4. All right, moving right along to numbers 5 and 6. Do these have a maximum or a minimum? So number 5 is going to have a minimum because this parabola opens up, which means the vertex is at the very bottom. And so now it's just a matter of finding the vertex. And the answer to the value is going to be the y-coordinate of the vertex. So if you want to do the opposite of b over 2a, it would look like this. So the opposite of negative 1 is positive 1. But now to get the value, you need to plug 1 in for x into the function. And what comes out will actually be the value of the minimum. So minimum will be answer part 1, and the value will be 3 minus 6, which is negative 3, plus 4, which is positive 1. Number 6, because this parabola opens upside down, it's going to have a maximum. And find the value the same way. The opposite of b, which is 8 over 2 times a. So this is negative 4, but the opposite of negative 4 is positive 4. So now to find the value of the maximum, we're going to put 4 in for both of the x's and see what comes out. So this is negative 16 plus 32, which is 16 minus 4. And so the value of the maximum is 12. All right, you got to solve numbers 7 and 8. You'll have to know the algebraic and the graphing method for these. So you just need to find the vertex and the 2 x-intercepts, if they exist. So the vertex, if you wanted to leave it like it is and just do opposite of b over 2a, so the x-coordinate of the vertex is negative 3. And now we're going to put negative 3 in to find out what the rest of the vertex is. So 9 minus 18 is negative 9, minus 16 is negative 25. So that's the vertex. And so since that's going to be more spaces than I've got, I'm just going to make the y-axis in 3s so it'll fit. So negative 3 is right here, and then 1, 2, 3, 4, 5, 6, 7, 8. That would be negative 24, and then just a little bit below that is my vertex. To find the x-intercepts, I'm going to use factoring because there are factors of negative 16 that add up to positive 6. It's positive 8 and minus 2. If you want to use quadratic formula here, that's okay. But my 2 x-intercepts are positive 2 and negative 8. And that's really all you need for these problems when you're solving graphically. Just these 3 points. The only thing I'm going to do is one slight adjustment. Because it says less than, that means these actual, I didn't mean to delete the whole thing, but these actual x-intercepts need to be open circles. They're not going to be a part of the solution. Thought I could just erase those x-intercepts, but it just did the whole thing. So if it had said or equal to, then they would be solid circles. All right, so now what this is saying is what part of this parabola lies below the x-axis. Well, the part that lies below the x-axis is this part. And we want to know, well, what are the x-coordinates that are from that part? Well, those are the x-coordinates that are between -8 and +2. So my answer in interval notation would just be this. So I'll just kind of talk you through the algebraic method. The only difference really with algebraic is you would go ahead and find these x-intercepts, and then you would put them on a number line. And you're going to do some testing. So test a number in this area, and in in this. So I'm going to test 3 different numbers. Doesn't matter what you pick. Like test -9. If you put -9 in for both of these x's and saw what comes out, you want to see if putting -9 in for x makes this true. Well, let's just see if it does. So -9 squared is 81 plus 6 times -9, that's -54 minus 16. So is that a negative number? 81 minus 54 is 27 minus 16 is 11. All right, so what I've proven here is the numbers left of -8, less than -8, do not work. So to test between -8 and 2, just pick any number in that range, and 0 is an easy choice. If you let these x's be 0, then you get -16 is less than 0. That's true. So we've proven that the numbers between -8 and 2, we already proved that with the graph. This is what you would do algebraically. You would find those x-intercepts and then test numbers around them. And then if we took the time to, so 0 is my test, over here I might test 3, and if you do, these are not going to work. 3 is not going to make this true. So I just wanted you to see the connection between the graphing method and the algebraic method. Okay, so for number 8, we'll set this up standard form. So I subtracted 14x, I subtracted 5. So do the same thing, we just need to find the vertex. So this is going to be the opposite of reduced form. This would be -7/3. So that's positive. Excuse me. So this is going to be +7/3 for the AOS. And if you're looking at decimal form, the 2.3. And now plug that back in. To get the rest of the vertex, you'll just plug that back in and you'll get -21.3. So again, you can just make the y-axis in 3s. So 2.3 and then a little bit below 7. And then to find the x-intercepts, you could use the quadratic formula, but this also factors. So that's the way I prefer, if factoring is possible. So if you're doing the box method, it's the factors of -15x squared that add up to -14x. So box method would probably be a good choice, or if you don't like the box method, use the quadratic formula. But in using factoring, I'm going to do, this is going to be -5, and this will be +1. So my two x-intercepts should be negative 1/3 and positive 5. All right, so let's just go ahead and get our graph situated. So here's I just realized can't count. I was thinking that looked a little bit weird. I did 1.3 instead of 2.3. So I should be over here. All right, that looks better. Negative 1/3, positive 5. And these are going to be solid circles in this case because it says or equal to. All right, so there's the graph. And now I'm going to interpret this. This is saying what part of the graph, as far as the x coordinates go, lies above the x-axis. Well, that's going to be this part and this part. So to represent this part, I'm going to go from negative infinity to this x coordinate, which was negative 1/3. And since it said or equal to, I'm going to include negative 1/3. And then I've got to combine that with the other side. So from 5 to positive infinity. So then the algebraic method would be, okay, this would be your number line. And so you're going to do your test. All right, so anything to the left of negative 1/3 should work. Anything between should not work. And then whatever you pick over here on the right of positive 5 should work. So that's really the only difference between the algebraic and the graphing method. All right, number 9, express the revenue R as a function of X. So we have to remember that revenue, I'll give you a strong hint here, revenue is price times quantity sold. Well, here's the price. Quantity sold is called X, so we just multiply those together. So there's the answer for A. What is the revenue? What is R if there's 100 units sold? So that's pretty easy. We just put 100 in for X and simplify. So just go to your calculator if you need to. And I got 14,000 for part B. What quantity X maximizes revenue? So again, this is really, if you want to go back and make a connection, this is what you did on numbers 5 and 6. How did you find the maximum or the minimum? So it's the same thing. So we need to find the vertex. So the opposite of B over 2 times A. So 150 divided by negative 1/10, or negative 2/10, is really the same thing as 150 divided by negative 1/5, but that's the same thing as multiplying by negative 5. So that should be the opposite of negative 750, which is positive 750. And then what is the maximum revenue? We just turn around and put that back in for X. For maximum revenue, we're going to replace X with 750. And go to your calculator again. 56,250. And then finally, part D, what price should the company charge to maximize revenue? So remember, this is the price function, and all we have to do is put in that number for X that maximizes revenue, and that's the 750. So all we're doing here is just taking that price and we're replacing X with 750. And that will give us our answer. And it looks like that's going to be $75. All right, and there's our answer for number 9. For number 10, I think I'm just going to kind of talk you through what should be done. It's pretty straightforward, especially this part A, draw the scatter diagram. All you're doing there is plotting points. So these are XY coordinates that need to be plotted. That's pretty basic. You probably want to change your units to make them all fit, and you can pick whatever unit you like. But overall, when you're done, if you do them in threes, these points are clustered pretty closely together. You'll find that your scatter diagram is, the points are going to be up here, clustered fairly closely together up in quadrant 1. And so based on the scatter diagram, you should see a linear relationship. The points should be clustered so closely together that they're trending in a positive slope line. And then letter C, you'll need to use that sheet and your graphing calculator. And you'll be able to use that sheet on your test. So make sure you're able to do the line of best fit to come up with that equation in your calculator using these points from the table. And then to get the answer for part D, you're going to take this line of best fit that you got in C. So you'll need to get the answer for letter C in order to do D. And you're just going to plug 26.5 in for X. And that'll get you the answer for part D. So I think that's probably easier than, I think everybody knows how to plot points. That's no problem. You should see that they're going to form a linear line, a linear relation. So really it's just a matter of knowing this on your calculator and then plugging the number in for part D into that line of best fit. All right, and then we do a little bit of review. Is the function f of x equals x squared over 2x plus 1 even, odd, or neither? So to test this, we're going to input negative x in for x and see what comes out. So the top becomes x squared. That's no different. But the bottom becomes negative 2x plus 1. And this is a little tricky, I guess, because when I replaced x with negative x on the bottom, it didn't actually change the entire denominator. Okay, so to make it odd, then either the numerator has to change completely or the denominator has to change completely. And that didn't really happen. So what I mean by change completely is this denominator needs to become negative 2x minus 1. And that did not happen. It changed partially, but not completely. So my answer for number 11 is going to be neither. Finally, number 12, using this graph, you'll have one like this on your test. Find the domain and range of the function. So the domain, it extends from -4 to +4. And the range is going from -1 to +3. Intercepts, we have x-intercepts of -1 and +1, and y-intercept -1. Is f symmetric with respect to the x, y, or the origin? Looks like we have symmetry with the y. The y-axis splits the graph up into two equal halves. If you fold on the y-axis, the two halves would come together. So it's going to be y-axis symmetry. Find f of 2. So let's find the point on this graph that has an x-coordinate of 2, and f of 2 then would be 1. It's the y value. For what values of x is y equal to 3? So you can always think of f of x as y. So let's see, do we have any order pairs that have a y of 3? Yep, we've got actually 2. And so we would say both 4 and -4. Where is the function, over what interval is the function below the x-axis? That's what this is saying. So it's below the x-axis in this interval. So that's between -1/2. It's kind of tricky because this is -1. So this would be -1/2 to +1/2. And since it doesn't say or equal to, we'll leave that as parenthesis. Is the function even, odd, or neither? Well, since it has y-axis symmetry, it's even. If it had origin symmetry, then it would be odd. And now, where is the graph increasing? Well, it's increasing from x is 0 to x is 4. And then let's see where it's decreasing from -4 to 0. Okay, I think we got it. That is your test review sheet for this test coming up. And I hope this helps. But if you still have any questions, need any help, let me know.